Morning, everybody. Today, what we're going to look at is a continuation of our trig ratio work. There are three major assessments once we get this one in. The first one was, can you write sine, cosine, and tangent equations if given the triangle and all of the information? The second one was, if I take some of the sides away, can you calculate the rest of the sides and solve the triangle that way? This third piece is going to be, if I take away the angle, can you calculate the angle? Which is a slightly different calculation what you're going to be plugging into your calculator. So I'm going to walk you through that. So, again, we have a right triangle. And we're going to be looking for angles today. And today I'm just going to talk about tangent angles. Okay? Because I want to give you a chance to really get tangent down before we throw sine and cosine. So just like what we did with sides. Okay? Start with some tangent and then add sine and cosine tomorrow. So we are looking for this side. This angle. This X. We don't know what it is. Son of a gun. Could be anything. I mean, it's going to be a very specific angle, but we'll get there. Okay? So, if we're using tangent today, remember, SOHCAHTOA. TOA is T-O-A. I need my opposite and my adjacent. So while I'm building these problems for you, I'm thinking, okay, I'm going to need to give you my opposite side, opposite of the angle, and my adjacent side, not the hypotenuse. Remember, we talked about this. Adjacent means next to, but this is my hypotenuse. Okay? It's across from the right angle, and it's my longest side. So, for the opposite side, I'm just going to make this 8. And for exactly no reason whatsoever, I'm going to make my adjacent 7. Okay? Now, quick reminder, and this is off on a different path, a tangent, you might say. If we wanted to find the hypotenuse right now, we could always just use the Pythagorean theorem. SOHCAHTOA and everything we're talking about right now will work, but you can always just use the Pythagorean theorem. Our good friend Pythagoras, cool guy. All right, so looking at this, I'm going to write the same equation that I've been writing for the last week. Okay? The equation doesn't change. What changes is our unknown. So what the variable is. So this is still, because it's opposite and adjacent, and you're only using tangent today, it will still be tan. My angle I don't know now. So angle X equals my opposite, which is 8, over my adjacent, which is 7. Okay? The nice thing about looking for angles is I don't have to rearrange the equation here at all. I just need to plug this into my calculator. But tangent is no longer what we plug in. What we're going to be plugging in, let me find it here, instead is arctan. So instead of pressing T for tan, you need to shift T to get arctan. Okay? That is the inverse function of tangent. So it's asking arctan of what? And then it's going to spit our angle back out. So if you look back at our original equation, it was tangent x equals 8 over 7. So if we're looking for our angle measurement, then arctan of 8 over 7 will give us that degree. But, and this is important, so let me talk about this really quick. This spit out a 0.85 degree angle. Okay? If we have an 8 and a 7, I would expect something much closer to 45 degrees than 0.85. So we've been talking about reasonability of answers. This answer does not seem reasonable to me. Even if there's nothing reasonable about this. I did something wrong. And for those of you that have already called me out on it, nicely done. I'm in radians, and that means I did the problem wrong. We need to be in degrees. So, arctan, 8 over 7. 48 degrees. That seems more reasonable to me. 48 point, remember we're rounding to the nearest hundredth, 48.81 for x. Just going to erase it here. So that is 48.81. Let me zip back up. Okay, So I have a 48.81 degree angle here. Does that seem reasonable? Well, I wanted it to be close to 45 because these are pretty similar measurements. And remember, the longer side should be across from the bigger angle. And if this is 48.81, this is going to be about 41. That's what is it, 41.19? Okay, this is the bigger angle. It should be across from the bigger side. Okay, so that's how you use arctan. If I give you two sides, that's how you will find your missing angle. Now, one of the things that you're going to notice with a lot of the problems is both of these angles need to be missing, right? Because if this is a 90 degree angle and this is a 30 degree angle, I don't need to use tangent. I can just remember that all three angles added together are going to give me 180. So you're going to have both angles missing all the time. So make sure that you're answering the correct one, because this is 48.81, that's 41.19. My mental math skills are deteriorating in isolation. So just make sure that you're answering the right question. I'm going to do just one more with you here, and then, what time? I'm going to do it 16? Yeah, I'm going to do one more with you here, and then I'm going to set you off into the mathematical wilderness. And because we're dealing with right triangles, I only have to erase the measurements. Let's do this, because I feel like I've seen a couple of these mistakes happen. Let's come up here. We're going to look for that angle now. And let's say this is 32. And let's say this is 60. Again, making these up off the top of my head. Okay. Oh, that's an interesting idea. No, not going to do it. Okay, so this is 32, this is 16, tangent of x, because we're still dealing with x as my degree measurement. I don't know it. I have to find it. It's a mystery. Across from 32, so 32 is my opposite. Remember, opposite over adjacent for tangent. 32 over 16. Okay, so to our fancy calculators. And this time we're going to remember, to make sure we're in degrees, which we are, Shift T for arctan of 32 over 16. Now, you can reduce this if you feel like you want to. If you want to reduce 32 over 16, 32 divided by 16 is 2. If you want to just do arctan of 2, that's fine. That will work, but you don't need to. We have a 63.43 degree angle for x. Okay, so that is it reasonable? Yeah. 32 should be a heck of a lot, is quite a bit bigger than 16. If this is 63, this is only going to be like 27, 26, something like that. So, yeah, the bigger side is across from the bigger angle. 63 seems perfectly reasonable. Yeah, that seems like a good, reasonable answer. I trust that answer. Feeling pretty good about that. Now, I said I was only going to give you one more sample problem, but I do want to show you this. It's the little brain thought that I just had. Okay, so we're just going to zip through this really quickly. Let's say this is 8, and this is 8. Okay? For those of you remembering and using your thinkers, okay, this is an isosceles triangle, right? Because I've got two sides that are congruent to each other. That is congruent to that. And if you recall, that also means that these are congruent. And an isosceles right triangle should mean that these are both 45 degree angles. Okay? So let's just do the equation and see if it works out. Tangent of x. There. We still need an x. Okay? Opposite over adjacent, 8 over 8, which actually, interestingly enough, is the same as the adjacent over the opposite, because we're an isosceles triangle. And also because the angle on the opposite side of the triangle is congruent, so they should be the same. Okay, to the arctan. Shift T to get arctan up. Arctan of 8 divided by 8. 45! Huzzah! Okay? So, and really what that means is, remember we're dealing with ratios. And anytime the ratio of this side to this side, the opposite and the adjacent, anytime that ends up being 1, it'll be a 45-degree angle. Because if the ratio is 1 to 1, that means that they're congruent. And our angle will be 45. Okay? So remember, we're still talking about ratios. I think that now it is time to give you a problem just to practice, and then the homework will be available to you. And I'm erasing the whole problem for exactly no reason. Let me give you a slightly awkward-looking triangle. Oh, yeah, he's awkward. That's okay. We'll love him anyway. All right, let's give ourselves an X there, and let's make that 13. I'll make this 25. Take a moment and find X. This is 25, this is 13. You're looking for this angle just to make sure you can see okay on my whiteboard, and go. Okay, looking at these, our equation is going to be tangent, because that's all we're using today. Tomorrow, you're going to need to start being able to distinguish between them. But today, we're just using tangent of my opposite over my adjacent. My angle is X. Opposite is 13 over 25 to the arctan. I feel heroic when I say that, and I recognize that it probably is not nearly as exciting as all of you think that it is. Or as I think it is for all of you, rather. 13 over 25. 27.47 degrees, which makes sense because this is opposite the smaller side now, so X equals 27.47. Remember, we're rounding to the nearest hundredth. I have not had to round up today, so don't assume that you're always rounding down. That's what we're looking at today, is the arctan. And tomorrow we're going to look at sine and cosine. So if the sides are going really well for you and have been going well, it's very similar. It's what's my missing piece and what equation can I use to solve for it. Okay? And today it's just tangent. It's all tangent today. Tomorrow is going to be a little bit trickier, and then there will be a day where we put all of them together. Okay? Homework is posted. Go ahead and get to work on it, and I will see all of you tomorrow.